Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app, and we'll keep sharing great conversations like the one we have for today. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. I'm also an investor in and advisor to more than 30 AI-first companies and a firm believer in the power of technology to make humans better. If you're passionate about changing the world with AI, or maybe just looking for your next adventure, let's talk. We learn from AI thought leaders weekly on this show, and of course, the added bonus is you get one AI fun fact each week. Today's fun fact: every new technology arrives with hope and unbridled promise. Some embrace technology to do good, and others exploit it to do harm. Such is the case with generative AI, text-to-image conversion services like DALL-E 2 and Stable Diffusion. We're only months into I'll call it the generative AI frenzy, and already the first Discord servers and subreddits have been set up by users with, we'll say, nefarious goals. In a thoughtful analysis by Abhishek Gupta from the Montreal AI Ethics Institute, we learn how users are teaming up to outsmart content filters designed to prevent hateful and lewd images from being generated and propagated online. It's clear there's a need for tighter control over how these LLMs are used. With great power comes great responsibility. I think my friend Spider-Man said that. We'll be discussing the potential of generative AI in the weeks ahead, but more important, the ethical and regulatory frameworks that we really need to make sure these technologies are used responsibly. As always, we'll link to the full article in today's show notes. But for now, shifting to this week's conversation, automated machine learning, or AutoML as we call it, is technology that automates the tasks required to build, deploy, and manage machine learning models that make automated decisions. Common AutoML tasks include algorithm selection, hyperparameter tuning, and even drift detection of data. There are literally dozens of AutoML platforms from startups as well as big tech companies like Amazon, Microsoft, and Google. It's a crowded space, but surprisingly, no single platform has achieved escape velocity. Today's guest spent more than a decade in engineering roles at tech-first companies like Instacart and Cruise, before realizing machine learning engineers need a better solution. Emmanuel started Sematic earlier this year and was part of the YC Summer 2022 batch. He recently raised a $3 million seed round from investors including Race Capital and Soma Capital. Thanks to friend of the podcast and former guest Hina from Samsung Next for the intro to Emmanuel. I've been involved personally with the AutoML space for about 5 years or so, and full disclosure, I'm on the board of Augur, which is in a related space. I've seen the space evolve and know there's much more room for innovation. I'm looking forward to getting an education about what's broken and what's ahead from a true machine learning pioneer. Without further ado, Emmanuel, it is my pleasure to welcome you to the podcast. Let's get started by maybe having you share a little bit more about your background and how you got into the space.
For sure. Thank you so much, Dan, for having me on. So I started my career about 15 years ago in academia, actually. So I'm originally from France. I started doing physics research at CERN, the big physics lab in Switzerland. So looking for the Higgs boson and supersymmetry at the Large Hadron Collider. And this was fascinating, and I learned tons of good practices around management of large data sets and large software releases. And I left academia in 2011, and I started working in tech. Worked as a just regular run-of-the-mill backend engineer at a number of startups in Europe, and eventually moved to the US in 2014, when, as you mentioned, I joined Instacart. At Instacart, I spent 4 years building all sorts of backend systems. What I learned really is how to build production scale systems. So like how to scale things like Postgres databases, Rails backends, Redis caches, and so on. And towards the end of my time at Instacart, I got closer to the machine learning and data science space as a sort of a callback to my academic years. At that time, I had been building software for about 6 years. And so I knew what it takes to build large-scale applications, but I could also understand the language of data science and machine learning thanks to my academic background. So thanks to the mentorship of Jeremy Stanley, who at the time was the VP of data science at Instacart, and now is the founder of this company called Anomalo, I was able to get back into that space, and I quickly realized that my real added value was really in building tooling because of this kind of double hat that I was wearing. And I realized the gap between the expectations of practitioners of data science and machine learning, so people that have master's degrees or even sometimes PhD in computer science, it's more specifically computer vision or statistics, and the available tooling. So as everybody knows, the first place that people start is a Jupyter Notebook, which is a very popular tool, very easy to use. It combines, iterative development with visualizations. But outside of that, it's not really, you don't really have a good toolkit to build production grade machine learning systems. So I started dabbling in that field. It was about 2017, I would say. And then in 2018, I had the opportunity to join Cruise, the self-driving car company in San Francisco. And I was really thrilled to be able to apply my sort of nascent ML ops knowledge to Cruise. And so I joined in 2018. And at the time, there was not much infrastructure around machine learning at Cruise. And the reason was that there was obviously machine learning on the Cruise cars at the time, but it was mostly confined to object detection. And the rest of the stack, like planning, controls, tracking, and so on, were still very much driven by heuristics, so algorithms instead of machine learning models. And that works quite well to have a vehicle drive itself on the road. But if you want to cover what's called the long tail of events, so things that happen more rarely, but are absolutely critical to address for a safety critical product such as a self-driving car, you need to move from algorithms and into machine learning models that are able to deal with situations that they've never seen before, but they're able to deal with it because of their training. So about, I think it was late 2018, Cruise decided to become an ML first company, which meant moving many of those pieces of the stack from algorithms to machine learning models. So that's when all the ML teams suddenly scaled up their hiring. And that's also when we decided to sort of found the ML platform team at Cruise. I think it was December 2018. I was one of the founding engineers of the machine learning platform team. I think we were about 10 engineers at the time, and everything was to do. Basically, at the time, people were mostly running workloads on their local machines or on servers laying around the office, which obviously it is not a very scalable way of doing things. People were struggling for sometimes weeks to access data sets that were collecting by the cars on the road. So this lack of tooling was really, it was really a problem for the company, not being able to move faster, get results faster. And even when you're able to train a model and get it to production, how do you retrain it? How do you automate this kind of feedback loop? Was really very difficult. It took an entire quarter sometimes to retrain models. Really not acceptable for a company that really wants to move fast and be a leader in that space. So this ML platform team grew fairly quickly. And by the time I left in April 2022, it was a full-blown department of about 80 engineers that was really building all sorts of tooling, from data infrastructure to model training tools, to data processing, to pipelining tools, and so on. I focused mostly on two areas. The first one was large-scale data processing. So you can think about MapReduce type of work. That was the first area that we tackled. basically building frameworks and tools for people to easily access those large amounts of data collected by the cruise cars. So as you can imagine, the cruise cars drive around San Francisco all day and all night, collect data with their sensors. You have LiDARs on the roof, you have radars on the mirrors, you have cameras and microphones all around. And this data comes back in the car to the warehouse. So we help offload this data into their cloud infrastructure, and some of it gets labeled. So it means it gets sent to a human workforce that's going to add, things like annotations, bounding boxes, and so on this data. And then this data needs to be accessible by ML engineers to produce the training data sets that are going to be used to train the models. So it's important that this data is easily accessible so that they can easily select the type of events they want to train on. For example, I want scenes at night with maybe some fog, maybe there's a pedestrian nearby, like very sort of constraining query parameters. And once they've made the selection, they need to be able to quickly convert this data set into a training data set. So the format of data that is good for streaming into our training platforms. So we built a tool based on Apache Beam, which is a very popular open source framework for data processing pipelines. And this was very popular internally, and we were able to scale it up to hundreds of users and really accelerated the way that people accessed data at Cruise. After that, I focused on pipelining, end-to-end pipelines. So Cruise has this concept of the continuous learning machine. This is a very, very high-level concept, almost like a moonshot, like a pipe dream of what an ideal ML system would be. The idea is that if you can automate as much as possible of the end-to-end training pipeline, so starting from this raw data that's been labeled that I mentioned earlier, all the way until the model is ready to get deployed to the car. So that means data mining, data selection, data cleaning, data processing, featureization, model training, model evaluation, simulation, all those tasks. If you can automate all of that, also converting the model to the hardware that's on the car, and also automate the feedback loop. So getting the data back, identifying moments where the model did not perform well. So for example, the car had to swerve, or there was a hard brake, or any of those indicators that something went wrong in one of the models. And if you can close this loop almost fully automated with very few human in the loop, it means your model can get better over time, week after week, without too much input from engineers. Because every week, maybe you have a new batch of data coming back from the road that's been labeled, and that you add to your training data sets so that the model explores the corners of the parameter space that it hadn't explored before, so that it starts treating those corner cases. So obviously, automating this loop requires a ton of infrastructure, because you have to chain many different third-party services. For example, your MapReduce data processing framework, whether it's like Spark or any other of those platforms, Hadoop or any of those, with your training clusters, so like typically a GPU cluster and so on. And then you probably have some in-house frameworks for like metrics and simulation and so on. Being able to chain all those pieces seamlessly with data contracts at each of the transitions between those services in a way that is sufficiently easy for end users, so ML engineers, to operate by themselves without too much assistance from infrastructure engineer, is obviously very challenging. So that's the focus that I had the last 2 years at Cruise, is building this kind of tooling that enables ML engineers, so people that have sort of baseline Python proficiency, but not necessarily large-scale cloud infrastructure proficiency, to be able to operate those large-scale pipelines and be able to debug them, implement them, upgrade them, and so on, autonomously, without having to require assistance from platform engineers. So this was fairly successful and really enabled those teams, so ML teams, to start accelerating much more their rates of sort of improvement of metrics, because suddenly they were able to experiment by themselves without requiring the help of infrastructure engineers. So this was fairly successful. And by the time I left, this platform was adopted by all the engineers at Cruise, supporting hundreds of thousands of executions per week and so on. And so that's when I left Cruise in April and founded Sematic right away. The idea of Sematic is to bring those learnings that me and the rest of the team got from working at Cruise all this time and doing all this kind of cutting edge technology and bring it to the rest of the industry. So bring those learnings and in a way that is open source so that people can even learn from the patterns that we use in the code. So that's what we did, and we launched the product in July this year. And we, as you mentioned, we just raised a raise of funding so that we can hire more people on the team. And so that's kind of what we're in the process of doing now and building out the product for even more adoption.
I teased in the intro that there have been a lot of approaches to AutoML, some that have been commercialized by big tech vendors and others from startups, open source, not open source, et cetera. Where's their need for Sematic? How's it going to be different from what's out there?
Yeah, so the typical AutoML solutions that you see out there will take a fairly standardized model, like let's say XGBoost or scikit-learn, that has a fairly well-defined data contract, and will essentially iterates on sets of parameters or sets of sampling strategies, for example, to try to find the best one. And that's very valuable, but it makes a lot of assumption about the type of model you're trying to train. So, for example, XGBoost or a scikit-learn is not deep learning. It's very suitable for many cases, optimization issues of funnels or sales or predictions or time series things and so on, but not necessarily for deep learning. And I'm sure there's also AutoML tools for deep learning. But my point is that all those tools are very suitable for one particular use case or set of use cases, but not necessarily generic enough to build those continuous learning machines. So Sematic itself does not necessarily see itself as an AutoML tool. Yes, our pitch on our website says continuous machine learning platform. And the idea is that we want to encourage end users to think about their system as a living system, not as like I train a model in a notebook and that's it. The model is going to be there forever and I never make changes to it. We try to encourage our users to think about their model as something that will drift and get worse over time. Without any retraining, the model after a few weeks is definitely going to lose its predictive power. It's going to have lots of incorrect predictions if you don't build this feedback loop to get the data back into the model. And so we encourage our users to think about their model as a living pipeline of, yes, you train the model and then you deploy it. It generates inferences in production, but you need to collect those inferences and have a way to score them, have a way to evaluate the ones that are correct or incorrect, or the level of correctness, so that you can enrich your training data sets with those failure modes. So our approach to continuous machine learning is at a higher level than just within the training loop of AutoML. It's really about building an ML system as a living pipeline, as opposed to like a one-off. I train the model and I ship it, and that's about it. Because this is exactly what we built at Cruise, and this is how the Cruise models were able to get better over time by learning from their own mistakes that they made on the road.
Is there any one particular aspect of managing the data pipeline that you feel like Sematic is better at than most? It seems like every AutoML platform has really one area of specialty. It's a broad set of tasks, but everyone focuses on one area.
Yeah, for sure. So our differentiating point with other similar tools is our sort of very low barrier to entry. Let me explain what I mean by that. What we noticed at Cruise and other jobs we had before is the gap that I mentioned between the expectations of the workforce and the tools that are available to them. Typically, those tools are built by software engineers, and the first wave of ML engineers and data scientists were typically former software engineers. So they had all the skills to build things like container images, deploy jobs to the cloud, investigate container logs, and so on. The new wave of ML engineers don't necessarily have this set of skills. The same way that 10 years ago, with tools such as Ruby on Rails, Heroku, and so on, you could suddenly deploy applications to the cloud without knowing how to spin up an Nginx server or without how to deploy a Postgres database and whatnot. You just had to click a few things in your interface, whether using Heroku or AWS or any of those tools. And things were mostly working out of the box without you needing to learn too much about the underlying technology. And this shift hasn't really happened yet in ML. In ML, people will start in a notebook that's very standard, This is the same thing as a web developer starting with a local Rails app, for example, or local Django app. But what happens after that? What happens once you've successfully trained your model on, say, a small data set in your notebook, and now you need to train it on the entire data set, like millions of data items potentially in the cloud. That requires a lot of skills, knowing how to package your local dependency into a container image, launch this job in the cloud, do all sorts of experiment tracking, also how do you enable traceability and so on. All those traceability and reproducibility, all those things do not come out of the box, out of those cloud platforms. So you need to build those additional layers. And so what we noticed is that there was this huge gap between the skills of the people that were joining the workforce now and the tooling that were available to them. As soon as you ask an ML engineer to build a Docker image and deploy a pipeline to the cloud, that's going to be a lot of work for them, and things that they haven't learned in school necessarily. That's not their domain of expertise. Some of them are obviously very curious and very skilled, and they're very talented folks, so they're able to pick up things. But obviously, that is work, that is time that is not allocated to actually analyzing the model, doing modeling, doing sifting through the data, and so on. So they spend a lot of time building their own makeshift tooling, as opposed to spending the time actually working on the model. So what we've learned at Cruise is that even though at Cruise we would hire, top of the crop, people from Stanford, MIT, and so on, very skilled people, very intelligent people, but still they needed tools that had a higher level of semantics. And there's no mystery why the company is called Sematic, because of course it's a portmanteau of semantic and automatic. And what we realized is that those users need high level tools. So what do they know? We need to meet them where they are. What do they know? They know Python because they use it in their notebooks. So that's great. They know typically pandas, data frames, and NumPy. They usually know those things. And so we're trying to meet them there. So we try to conceptualize the pipeline as basically Python functions, so just encapsulations of business logic that can be chained together, and that's it. Everything else, storing artifacts, keeping track of runs, ensuring traceability, reproducibility, and so on, is behind the scene. It's not a requirement for them to even learn how it works. It's just guaranteed out of the box. So we pride ourselves on having the easiest onboarding of all the products out there. Within a few hours, somebody can already run a pipeline either locally or in the cloud, because we try to have the simplest concepts out there. We're really trying to meet people where they are, and give them the tool to, if they want to learn more, obviously they can, but they can also just keep operating at this high level. And we've got a lot of good feedback from the community about how easy it was for them to onboard, how our UI is making them gain a lot of time, because suddenly they don't have to forage, cloud storage or even their own hard drive, or where did I store my file? Where did I store my data frame? And how do I deserialize it now? How do I open it? How do I visualize my data? Oh my God, it's I don't know where it is. And so by having those things come out of the box, experiment tracking, visualizations, and so on, we save them all this trouble from having to do this. So it means they can move much faster, basically.
What's the architecture of Sematic? Are you building the models and then handing off the artifact to be hosted elsewhere, or will Sematic be a service where you're training the models, managing the data pipelines, and hosting the models and serving the models?
That's
your
good question.
approach?
So at this time, Sematic is only an open source product, right? So it, as you mentioned, is a very early product. We started about 6 months ago. So at this time, it's mostly an open source product, which means that users can use Sematic to build their end-to-end pipelines to run either on a local machine or in a cloud deployment if they wish so. In the next few months, we will be releasing a hosted service of Sematic for people to be able to use it without having to deploy anything in their cloud infrastructure. So at this time, we do not take care of serving the model. So people will build this end-to-end pipeline that will read data from their data warehouse, whatever it's like, the Redshift, Snowflake, BigQueries of the world. We'll train the model using probably GPUs or whatever resources they need in a Kubernetes cluster, and once the model is trained, they have an artifact that they can access, and they're free to deploy it as they wish. People use, for example, SageMaker or BentoML or any of those tools to do model serving. The reason why we haven't focused yet on model serving is that every model or every even ML system has a different way of serving. Some people will do batch inference, which means I have my model, I will generate prediction for those 10,000 users, for example. I'm going to store it in a database, and that's it. It's like almost offline predictions. You just store those inferences. Others do live, like online inference, where they put the model behind an endpoint, for example, a RESTful or gRPC endpoints, and the production app will send features in real time and get predictions in return. That's another type of inferences. And then depending on the type of model, if it's like a PyTorch model or a TensorFlow model or scikit-learn XGBoost, the way to serve it is also different. And if you need to do high performance serving with low latency, then you need to have some amount of caching of the model and so on. So it's a product in itself. Model serving is a product in itself, which is why we decided to not focus on this area. Also because we don't have the expertise yet, because at Cruise, serving was happening on the car itself. So the models were getting deployed on the car. So we never had to build the infrastructure to serve models because they were all on the car. So right now we're focusing more on how do you go from your raw data sitting in your data warehouse to having a trained model with evaluation metrics and so on. Once you have this, then you're free to use the toolkit, the tools of your choosing to deploy it. Of course, the last step in your pipeline could typically be calling this external service, SageMaker or whatever else, to deploy your model if you want so. However, I think deploying models automatically may be a little bit dangerous, obviously, unless you have a way to direct traffic between your different model candidates. But what happens usually is that there's a manual, there's a kind of a human in the loop kind of element to it, where you have a number of model candidates. You can compare metrics between the models, like, okay, this one is suitable. Maybe you probably definitely want to run regression testing. This is something that we actually enable with Sematic, and some of our users are using Sematic for this purpose. Regression testing is a very important part of the workflow before putting any model in production. Regression testing is essentially the idea that you want to run your new model on a sort of reference golden data set to make sure there was no regressions. For example, at Cruise, we had a huge data set of scenes that had occurred on the road where we had noticed issues. And so we fixed those issues. It's very much like test-driven development. When you have a bug, you write the test that reproduced the bug, and you fix the bug, the test pass, and then you keep the test forever to make sure that you never regress on that particular feature. The same needs to happen in machine learning. So that can be also automated. Once your model is trained, you can automate regression testing to make sure that all your sort of test scenarios still pass. This is very important to guarantee safety in machine learning, not only safety of the self-driving car, which obviously, like, this is physical safety of the users, of people on the road, other cars and so on, but also safety online. For example, if you're training a conversational bot to do, support or animation in a Discord server or whatever it is, it's very important that your model does not start insulting people, for example. That's a very trivial requirement. So you must make sure that when the model gets certain inputs, then it's not going to start insulting people. And there's also of biases that can be introduced by, like, facial recognition algorithms and so on. So having a strong regression testing framework is very important for a safe model deployment. That can be done as part of the automated pipeline that I mentioned before. And so to go back to the deployment part, there's always a human that's going to compare the different candidates, look at metrics, look at the results of the regression testing, and decide, yes, this model is safe to go to production. I'm going to click the button and automate the deployment. Now, obviously, you could have systems where you always deploy the model. Doesn't mean you send traffic to it. You just deploy it, and then you progressively send more traffic. But this requires a lot more automation from the ML teams, which I think a lot of companies are not yet at. So to answer your question, we're not focused on deployment yet. We're focused on the end-to-end training pipelines.
I'm fascinated by this idea that we develop ML-based software fundamentally differently than the way we develop traditional software, which, for lack of a better term, call it code first as opposed to data first. And I thought your explanation or your description of what tools and what skills an ML first engineer has are different from what a traditional software developer might have. Question for you is, given that I think it's not too controversial to say all software increasingly will be ML first. Will there be a time when tools like Sematic really make the role of the traditional software developer obsolete, because every ML engineer will be able to do all the things that a traditional software engineer could do?
Yeah, that's a great question. I think we always, every time we see a new layer of technology or a new wave of technology, we're always worried about certain jobs disappearing and so on. But the reality is jobs just mutate. A software engineer in the 90s that, as I mentioned, had to learn how to deploy even a server and how to host those things. Obviously, those skills are not necessary anymore. And all the people that I worked at all my previous jobs probably wouldn't even know how to host their own servers, because you have that out of the box from, GCP and AWS and whatnot. So just the set of skills evolve. That's the way I see it. And so I made this parallel earlier on with Ruby on Rails. Before being a Python developer and working in the machine learning space, I was a Ruby on Rails developer for a few years. And a tool like Ruby on Rails really, for all its, qualities and flaws, and, people can comment on it, whatever, but it has enabled a lot of people to build large scale applications fairly easily because it comes with a set of good practices, a set of industry best practices. For example, separates, your model, your view, your controller, write your unit tests, write your functional tests, and so on. Things that before that, some people would do. The most sort of skilled engineers would know how to structure those things in their app, but suddenly the framework itself prescribed the usage of those patterns of doing unit testing almost systematically on all of your code and so on. And thanks to those tools, Django, Ruby on Rails, Heroku that I mentioned before, a lot of engineers of all skills, either they're like students just getting started or veterans that have been struggling for years with infrastructure, suddenly they're able to build a prototype quickly within a few hours on a laptop and deploy it publicly, and then scale it to become multi-billion dollar companies. I worked at Instacart for 4 years. Instacart has a set of Rails app that is powering the entire business. I mean, I'm sure now, I left 5 years ago, so I'm sure that there are many more systems now. But when I joined in 2014, it was essentially a single monolithic Rails app. So my point is, those tools can pick up people where they are in their learning curve, so regardless of what the skills are, and then carry them to a large scale, like a large web app scale for Ruby on Rails. We have the same idea with Sematic. It can pick you up where you are. If you're just maybe in your notebook and you're like, okay, my notebook is fine, but now I want to be able to scale this up. I want to be able to go through code review, to collaborate with the rest of my team. I want to modularize my code so that I can import in different locations. So I need to leave the notebook. Where do I go now? Well, I don't really want to start from scratch. Well, I'm going to use Sematic, because Sematic has good practices about how to organize the steps in my pipeline, how to ensure the data contracts. It comes with the visualizations that I'm familiar with from the notebooks. It comes with lineage tracking and so on. So I don't think that those jobs are going to disappear. They're just going to mutate. It's just going to change, evolve. People are going to learn new skills and move forward up the stack potentially. And so what we've noticed, as I mentioned, is this gap between the skills of software engineers and the data first engineers like ML engineers and data scientists. And I think this is where the industry is a little bit at a breaking point, in that a lot of companies have invested in AI and ML because they can see the potential value, and they've had the first wins from having the first few models deployed in production, but they're struggling now because those systems are not maintainable, because they were not built with good practices, and maybe the owners have left the company. And some reports have mentioned that 80% of ML projects turns out to become deprecated or not being used in production because their owners leave the company, and so nobody knows how to pick it up and so on. And this is because of the lack of standardization of good practices across the industry. And modestly, this is what Sematic is trying to do. It's trying to come in and not impose anything, that just suggest good practices. For example, it should be clear to you what is coming in and out of each of your step in your pipeline. What is the data contract between those steps? Have no statefulness whatsoever. Everything that needs to be used for your pipeline should be parameterized as an input to your pipeline step, and anything that has been produced as an output, whether it's a data set or a model, should be also returned as an output of your pipeline step so that it is tracked. All those kind of good practices, this is what we're trying to kind of bring into the industry now, so that this transition from data first, but not very scalable in terms of the workforce and the code bases, to becoming those data first applications, entire applications, basically.
So you have a big vision for where Sematic can go, and obviously, what you just described, we're potentially on the precipice of changing how software is developed and delivered. This is a big deal. Talk us through when Sematic is wildly successful and it's achieved your vision. How's the world a different place?
Yeah, so one thing that we really learned at Cruise that was a very valuable experience, and that's definitely an idea, a concept that I want to bring into the industry, is the importance of standardizing the descriptions of assets across the industry. Of course, we did it at Cruise across the company. That's already was a lot of work, but the same concept applies to the industry. The idea is that different teams across the company would describe the same assets in the same way. So for example, if it's a BigQuery table or a PyTorch model or a set of evaluation metrics, any of those things that are part of the sort of machine learning workflow, all those assets need to be described in the same way so that they are interoperable between systems. It means that different teams can have different ways of training the model, but the data contracts, the way you describe the input data, the way you describe the output model, all those things needs to be standardized so that you can have more of a plug and play approach to building your code. You can, for example, compare this idea to look at, for example, Docker images, the concept of a Docker image to represent a container. This is a very powerful, because now you can deploy containers thanks to Docker images everywhere, on Kubernetes, on VMs, anywhere, or on any cloud architecture, even on your local machine, on your MacBook, you can do it as well, thanks to this kind of standard of describing containers. And this is obviously for the infrastructure world. The same thing needs to happen in machine learning, where you need to have a standardization of the description of assets so that those assets are also interoperable between systems. Imagine a world in which you produce a model with one dedicated service, maybe that's expert at like GPU training, for example. And so you're gonna use this service to train your model. Now you want to use this model to generate inferences and visualize those inferences. Maybe you want to use a different system for that. The only way that this works is if this asset is portable between those systems. And obviously, there are competing forces here, because some businesses will want to lock everything down to make sure that people stay within their walls and keep using their tools. And that's one approach. Another approach is to try to align across the industry on those standard descriptions of ML assets, so that this kind of large ecosystem of tools that you mentioned in the intro, that yes, it's a very crowded space, some would say even fragmented. It wouldn't matter if that was the case, as long as the assets are portable between those systems. And right now, the primitives to describe those things are extremely low level. A PyTorch model, you can pickle it, like it's a way of serializing a Python object. I'm sure you can also output the weights in some sort of JSON format and so on, but it's really hard to plug and play it in different services out there. So I kind of long-term vision, and obviously, we're ways not there yet at all, but our long-term vision would be to have this ecosystem of standardized description of ML assets, open standards, so that the industry can stop fighting over what tool is the best and what format is the best, and just compete over the actual features and the benefit that they add to their users, as opposed to trying to get people to adopt different paradigms.
Emmanuel, the time has flown by, but we're bad out of time. But answer one last question for me before I'm letting you go. As consumers, we've heard about the hype behind autonomous vehicles for at least a decade in Silicon Valley, and we've all consistently been disappointed by the actual performance. You spent a long time in the trenches. You mentioned, moving from kind of a heuristics driven model to an ML model with Cruise, and you've seen a lot of the challenges of getting self-driving cars to market. As a consumer, How would you describe the current state of technology, and give me a year? When will you feel comfortable getting into let's say a self-driving taxi or robo-taxi and going up and down 101?
Yeah, for sure. So to answer this question directly, the year is right now. Cruise is already running a commercial service in San Francisco. Waymo also just got approved for it. So obviously that's not up and down the one-on-one on the coast, but that's actually the point of my more high-level answer to this question, is that there is a huge gap between operating a robo-taxi within a certain geofenced area at certain hours of the day, which is what Cruise is doing, and operating anywhere, which is what the Tesla and other driving, full self-driving is trying to do. And I don't even necessarily know if this is ever going to happen, ever. However, operating taxis within geofenced areas is much more approachable and is already working. And, Cruise decided to choose San Francisco as its first sort of area to launch the product, because obviously the company was founded here and it would be like very symbolically powerful to launch here. But there's been other companies that have been operating services on like campuses, hospitals, or airports, in which those technology are much more approachable. So of course, I think the danger of the hype is that it made everybody believe that suddenly your own car is going to be able to drive you anywhere and you can just relax. Obviously, as every hype, there's a level of storytelling and like of bending the truth. More realistically, it's going to be a gradual progress from having certain vehicles operate within a certain area and providing this service to maybe decades from now, going maybe to the suburbs and maybe a bit beyond. And if ever we'll have a fully autonomous set of cars that can go anywhere, I can't really answer that question, but at least I'm confident about robotaxi aspect. And that's quite important to me because as a European, obviously I have a love for public transit. I spend a lot of time in Paris where the metro system is exceptional. The bus network is also very good. And many other cities in Europe have the same systems. And everybody knows that in the US, it's a bit more challenging. Some large cities like New York City has a pretty good subway system, but even San Francisco is kind of struggling there. And I realized working at Cruise that actually maybe a solution to that is, instead of trying to convince local governments to fund those transit systems that are extremely hard to fund because of the low density of habitations in those cities, instead having fleets of robotaxis that can automatically sort of reassign themselves to different areas of the city is potentially a solution to the lack of public transit. So the future where people who do not have a driver's license, who are not even in age of driving or too old to drive, or have some sort of disability that does not enable them to drive, will be able to benefit from those fleets of autonomous vehicles. And it's already the case in San Francisco. Cruise is launching right now in, I think it's Phoenix and also Austin, Texas, Phoenix, Arizona, and Austin, Texas. And so I'm confident that within the next few years, they will scale this across the US, and it will enable tons of communities that until now haven't had access to public transit to have access to those other modes of transportation.
Knowing what you know about the technology and about potential safety issues, what's the one thing that you look for when you get in a robo-taxi that might indicate it's either safe or not safe?
Yeah. So I'm a cyclist also. I love to ride my bike around the Bay Area. And so obviously, the interactions between cyclists and cars is well documented. And I actually feel much safer with a robot than a human driver, because the human driver almost invariably will get frustrated at me from just being there on the road. So some people are even too polite. They don't want to pass you, or like they give you the right of way when they should take it, and so on. So a robot, at least I know that they will take the time to go around. They will leave me enough room and so on. So actually I feel safer when I see, even as a pedestrian, when I see a Cruise car come up, I know that I could behave like an idiot and the car would still stop. Obviously there's many cases of videos of where you can see that, of people trying to stop the cars on road and so on. Obviously I don't encourage this behavior, but my point is that the robotaxis never get tired, never get drunk, never get frustrated, never get angry. They may run out of battery, and that's about it. I'm actually more enthusiastic about the safety of self-driving car than human driving. Humans are terrible drivers. We get tired, we get angry. We should just stop driving, period.
I feel better having heard you say that. Glad to know. Emmanuel, this has been great. Where can the audience learn more about you and Sematic?
For sure. So they can learn about us at sematic.dev. And from there, they can find all our content. We have a Discord server. We have a GitHub repo. Of course, we are looking for GitHub stars to help us promote the products. So anybody who's interested in bringing more sanity into their machine learning pipelines and good practices and how to scale it to the cloud, come into our Discord server and chat with us. We'd be really happy to help you.
Emmanuel, thanks for hanging out. This has been a lot of fun.
Yeah, thank you so much for having me.
Yeah, congrats on the launch and the raise, and we are all rooting for you to succeed.
Thank you so much.
Good stuff. Well, that's it for this week on AI and the future of work. As always, I'm your host, Dan Turchin, but of course, we're back next week with another fascinating guest.